Okay. So we're talking about essential statistics. Okay. So we so there are two main types, okay, or two main things that we do as part of uh, descriptive statistics, essential statistics. We have something called as measure of central tendency and measure of dispersion. Okay. So measure of central tendency talks about, you know, about the data that represents, or that is like, so data that can represent your entire data set. Okay. So let's say I was saying that if I ask you how many hours do you study per day, right? So you will not say yesterday I read 6 hours, before that 3 hours, before that zero. You will not tell me entire story, correct? आप बोलोगे on average I study 3 hours, or on average I study 4 hours, whatever. So when you say on average, it's understood that someday you will study less than 3 hours, someday you will study more than 3 hours. See, average means what? Okay. So average means some days you will study less than 3 hours, someday you will study more than 4 hours. But that average, which is mean, is representing a value which can tell me the entire story. You don't have to explain me what you do on every day. One single sentence, and I can understand the entire meaning, correct? That is
Yeah.
what is called as essential statistics, or for that matter, your central tendency, right? Now, we start, let's say we have session at 6 o'clock, suppose, right? Now, it's not possible to start the session exactly at 6 o'clock, correct? Someday we'll start session before 6 o'clock, or 1 minute before 6 o'clock, someday after 1 minute, right? But if you take average, it will come around 6, right? That's what we say. Okay, 6 o'clock. So your first important metric is mean, and mean represents, okay, your entire data. Mean represents your entire data, correct? Now, if I try to, okay, so let me show you one Excel. I'm going to show you with some data. I don't know, my system last 3-4 days it's behaving very slow. कुछ virus आ गया है क्या? I'm not sure. 1 second. Can you see my Excel file?
Yeah.
Okay. So let's say I take some numbers. I take 20, then 25, 25, 30, 30, 30, okay, 35, 35, 40. Okay. Suppose these are my numbers. Now, if I need to find mean, okay, what will be the mean of this value?
Total sum by
Total
uh,
sum by number of values.
mm,
Okay. So what do you do here? You say, you can directly say average, right? In
yeah.
Excel. Okay. So you can say equal to average, and you will say these numbers. So mean is average. Arithmetic mean is average. So you get 30. 30 is your mean. Now tell me what is the median, and tell me the mode. So
Median 30.
median 30, this is your median, correct? So
Yeah.
median is also 30. What is mode?
Mode mostly occurring value, max
तो
occurring
हाँ, तो कौन सा है?
30.
30. So if you see, if your data is normal, right? This is called normally distributed data, and probably you'll have it at your higher classes when you talk about continuous data, okay, multiple data. So your mean median mode will be very similar, will be almost in same range. When you're talking about normal data, okay, your mean median mode will be in same range. Okay. Now, okay, so if I have to use to describe your process, okay, how many hours you study, you can use mean or median. But generally we prefer mean because mean uses all the data, right? Mean uses all the data. Median doesn't use all the data. So median will only look at the medial value, right? So so that's why we prefer mean. But let's say if I get one outlier, 990. So let's say every day you study for 4 hours, 5 hours, and one day you study for 24 hours. So what will happen to your mean? Now you see your mean
changes.
changes, everything will change, but mean will change by a large value. From 30 it became 126. Median will be average of these 30 and 30, so it will be 30 only.
Yeah.
Mode will be 30. So for numerical data, median mode doesn't have any significance. Mode is significant for your categorical data. Okay, you want to see which is the most occurring value, but not for um, mean. So okay, so for numerical data, mode is probably the least used value. Of course, it has its own significant. Okay, but probably least used. So mostly used values are your mean and median, right? Now you see we added one outlier, one extreme high value or extremely low value. Okay, outlier means something which does not go with most of the data that you have. Okay, so most of the data is between 20 and 50, right? A gap of 5. So all this data is a gap of 5 or 6 or 10. Suddenly you see from 40 it became 990. So your mean became 126. Okay, median did not change. So what happens? Median has an advantage that, so generally we use average, we use mean, okay? But median has an advantage that it ignores outliers. Just because you studied one day 24 hours doesn't mean that your average should become high. Here you see, just because you have one very high value, average became 126. So when I say average is 126, see, forget about the data. Don't see the data. If I tell you, okay, average is 126, then what will you think? You will think, acha, average 126 hai, so value will be around 90, 100, 140, 150. Correct?
Yeah.
दिमाग में यही आता है ना. अगर मैं बोलूंगा एवरेज 126 है तो मोस्टली इन योर माइंड विल कम 90, 100 होगा, 110, 20 होगा, 30 होगा, 40 होगा, 50 होगा. You will neither think 990, you will neither think uh, you know two digits like 30, 40. And you see average is higher than most of the values. Okay, so what happens, your mean changes a lot, is very sensitive to outliers. Your mean is very sensitive to outliers. Okay, that's why what we do, we don't prefer to use mean when you have outliers. Outliers hai, so we prefer median, not mean. But if data is normal, if the question says normal data, normally distributed data, normal data, then of course you can use mean. But when you expect outliers, you go with median. See, median changes little bit. It goes to the right, but it is like still 30 only. I'll put one more 800 here. If you put one more 800, now median will be this 30. If I put one more, let's say 700 something, now median will become average of 30 and 35. It will be like 32.2. So even after adding 3 outliers, your median is not changing much, correct? And
Yeah.
your mean will be like 500, 400. Okay, it's not right representation of the data. So when you have an outlier, this is a very favorite question. Okay, you'll get in the exam. When you have an outliers, your mean is mean is highly affected, is very sensitive to outliers. Median is less affected. Okay, so we prefer to use median when you have outliers. So outliers are ignored when you talk about median. Okay, outliers will not have any impact on mode. No, absolutely no impact. Very little impact on median, very little impact. And mean, very high impact. So we tend to ignore outliers. Okay, so we use median. Make sense?
Yeah.
Cool. So now, so this is about mean, median, mode. Now, so I think last time I showed you, let's say I want to start an ice cream shop, correct? And um, to start, you don't need to, I mean, जब business start करते हैं, तो we don't start everything together, right? We'll just start with one flavor. Okay. So if you start with one flavor, which flavor should you start with? Okay. मुझे chocolate अच्छा लगता है, तो I'll start with chocolate. No, right? Because you are planning to sell. So what most people like, that's what you're going to manufacture. So if most people
Yeah.
like vanilla, then you'll start vanilla ice cream shop, right? Or ice cream manufacturing plant. Slowly you will add, one more flavor, one more flavor, one more flavor, right? So as you keep on increasing, then you will pick what is the most used. अगर business खोल रहे हैं तो you will sell something that is mostly used, right? By people, right? So that's where mode comes into picture, right? So
Yeah.
outlier है तो median, नहीं है तो mean. Make sense?
Yeah.
Okay. Now let's go here. So this is how to calculate mean, median, mode. Next is okay. So this is the distribution of data. Okay, so this is a question here. Okay. Now let's say you want to admit your cousin to a school. Okay, you have a cousin, you are recommending a school. So what you do is you go to a school and you okay, try to evaluate two schools. So there are two schools in your area. Okay, there are two schools in your area, and you want to evaluate your school. Okay, which school is probably better, so that you can put your cousin in that school. Okay, and so what you do, you go and look at their 10th class marks scored by their students. Okay, so you ask the student, you ask the principal, can you please give me the marks scored by all your students the last 10th class board exam? So school A, these are the marks that their students have got, and these are the marks you know scored by students of school B. Okay, so now if you take mean is 73 for A, 65 for B. If you take median is school A is 70 and school B is 43. And mode is 99 and 70. What does this tell you?
We need to check mean and median.
सर आप कुछ बोल रहे थे, प्लीज टेल।
मीन एंड मीडियन चेक करना।
हाँ हाँ।
नॉर्मल डेटा तो रेंज सबका सेम है इन स्कूल ए।
हाँ हाँ। So which you think, which see, so what message do you get? अगर मैं पूछूं आपसे कि ये क्या, what message are you getting? तो क्या क्या करोगे आप? What message are you getting from this data? हम्म। ये मीन मीडियन मोड तो आ गया, आई हैव कैलकुलेटेड फॉर यू। लाइक इससे मतलब क्या, आपको क्या समझ में आता है? व्हाट डू यू अंडरस्टैंड फ्रॉम दिस?
कौन सा स्कूल बेटर रहेगा?
कौन सा रहेगा बताओ?
स्कूल ए।
स्कूल ए बेटर रहेगा, क्यों? See, कौन सा बेटर रहेगा इज नॉट, इट्स नॉट यू नो simple question, right? It's not a very simple question. Okay. So if you look at this, you know, data, okay, what do you understand? ये जो स्कूल ए का मीन एंड मीडियन इज ऑलमोस्ट ऑलमोस्ट सेम, राइट?
या।
एंड स्कूल बी का देखो कितना डिफरेंस है, 65, 43, 99, राइट? 99 मोड है, मोड इज 99, मतलब मैक्स मोस्ट ऑफ द वैल्यूज आर 99. Okay, most of the values are 99, still your mean is less. Most of your values are 99, but still your mean is less. That means there are very few students, mean and median both are lower than median. That means there are very few students, okay, who have very high value, but most of the students have lower values. Okay, median 43 matlab, median means half number, right? So if you have 1,000 values, that means 500 values are less than 43. Imagine, matlab half students have got less than 43, right? So
या।
there are very, some brilliant student in school B. There are brilliant school student in school B, but school A has more consistent result. Consistent. Okay. So when you see all this together, that means they are more consistent. Here, they are not consistent. Most of the values are much lower. Only few values are higher, right? Because 43 median matlab half of the, so you have 9900 also, but your mid value is 43. That means
या।
43 से कम जितना है वो उतना ही आपको 90 100 तक भी है spread. Okay, so we'll talk about spread in next session. Okay, so this is your difference between mean and median. Okay,
या।
so we expect values to be more consistent, right? Now, not to create the histogram table, right? So what you do, you have got those values. So first you have to create the range, right? So 0 to 9, 10 to 19, 20 to 29, 30 to 39. We created these 4 values. उसमें आप based on the values that you have, you will put them in the group. Okay. And then you will draw a histogram. So you get a histogram, something like this. Right? You have histogram. So you create a histogram like this. Okay. So this is what we have already done, right? Okay. So remember, okay, so this is about handling one numeric value or one category value is drawing those bar graph or pie chart. Now, when you're dealing with two numeric values, scatter plot. Okay, now this diagram, if you see, this talks about two columns, temperature or ice cream sales. Okay, what was the average daily temperature? Okay, so let's say this is 1st of September. On 1st September, average temperature was 25.4 degrees Celsius और आपने आइसक्रीम बेचा 3,400 रुपीज का. So you sold ice cream for 3,400 rupees. Temperature 25.4. Okay, then you have 2nd September 32.8 and the sale was 4,500. Then 36.4 sale was 5,800. So these are the temperature recorded, average temperature for that day, or maybe highest temperature बोल दो आप for the day, and this is the sale of ice cream. Okay, so now you have two columns and both of these columns are numeric columns, not categorical column, right? Both of these are your numeric columns. So when you have something like that, we create scatter plot. Scatter plot में you put one variable on X and other variable on Y. You create one variable on X, other variable on Y. Okay, and you plot 25.4, तो x-axis पे 25.4 and 3,400. So ये point आ गया. Okay, so each point here represents two values, one on x-axis, one on y-axis. This is called scatter plot. Scatter plot will be dots. And when you create scatter plot, it tells you whether there is any relationship between temperature and sale, x and y or not. Is there any relationship between x and y? Is there any relationship between x and y? X में आपका temperature है, y में आपका amount है. So are they related? Are they related? So if you see the entire data, what do you notice? As temperature increases, sales also increases, correct? As temperature increases, ice cream sale also increases. That means if the temperature is high, if it is hot on that day, you expect more ice cream to sell. Okay, so we say this is called correlation, and I think that is the next section we'll talk about Pearson correlation and other value that correlation. Correlation talks about the relationship between two values. Are they related? Okay, so if correlation value is more than 0.5 minus or plus, we say they are correlated. Okay, 0.8, 0.9 means strongly correlated. 6, 7 means weakly correlated. So your correlation value will range from -1 to +1. What is -1? We say negative correlation. अब यहाँ देखो, as you increase temperature, okay, sales is increasing. अगर हम उसको रिवर्स कर देते हैं, ओके, अगर टेम्परेचर कम है, सेल्स ज्यादा है, ओके, एंड एज यू कम डाउन, राइट, so your sales is high when temperature is low, and when temperature increases your sales comes down, so that then we say it is negatively correlation. Okay, they are negatively correlated. Correlation is negative. Inverse correlation. Okay, and when you have inverse correlation, your correlation value will be correlation value will be
Less one.
Negative. Okay. So when it is positive correlation, your correlation value is positive, and when you go down, your correlation value will be negative. Correct?
Yeah.
Okay. Anyway, you don't have geometric mean, harmonic mean, so we will ignore. Okay, so yeah. Now we'll talk about, okay, so, okay, we'll just talk about this. I don't see this in your syllabus, but let's talk about this. So what I said, what's up, Lucinci? What was Lucinci? 1 second. Okay, so if you see this data, normal data, right here, mean, median, mode is almost same. This is what we did in the Excel, right? So in Excel, what we said, like, if your data is normally distributed, your mean, median, mode will be at center, okay, and it will be almost same. But when data is skewed, then your mean, median, mode will not be same. Okay. Now, if you take this data, left side, mode is high, median is lower than mode, and mean is even more lower. So I told you, when you have skewed data, outliers, mean will change, will go back or front very fast than median. So mean is going here, we are adding values on the lower side. So if you remember the school example, the marks that we discussed, school example, that falls under negatively skewed graph. Mode was 90, 99, I think. Median was
40.
correct, right? So when you have outliers on the left side, your mean, median, mode will be lower than mode mostly, and mean will be much lower when you add a lower value. And when you add a higher value, mean will increase very fast. The first example that we did in Excel, mean increased very fast. So when mean increases very fast on the right side, we say positively skewed graph. Positively skewed graph will have uh, you know positive outliers, right side outliers. So, okay, mean will be on the right side. How do you remember? Look at the tail, okay? When you draw this graph, most of the values are on the, on the lower, right? So, this is called hump and this is called tail. Tail is going towards right-hand side. Tail is going towards right-hand side. So, x-axis में क्या होता है? Right side is positive. That's why we say positively skewed graph. So look at the tail. Where is tail going? Is tail going towards positive x-axis or tail is going towards negative x-axis? If the tail is going towards positive x-axis, if the tail is going towards,
Positive axis.
yes, if the tail is going towards positive x-axis, if tail is going towards positive x-axis side, we say it is positively skewed graph. Okay, we say it is positively skewed graph. All right. So you have positively skewed graph, you have negatively skewed graph. Now let's talk about variation. Now in variation, okay, there are few metric. The first metric is called range. What is range?
Highest number minus lowest number.
Perfect, very good. Highest number minus lowest number. That is called range. Okay. So here if you see, range will be 100 minus 5, 95. Okay, higher the range, higher is the variation. Higher the range, higher is variation.
Okay.
Okay, so we say higher variation, and higher variation is not good. Okay, higher variation is not good generally. Okay, then you have interquartile range. What is interquartile range? To understand interquartile range, you
Q3.
need to understand quartile, correct? So क्वार्टल कैसे कैलकुलेट करते हैं?
IQR Q3 minus Q1.
हाँ, but how do you calculate Q1, Q3, Q2?
Divide first quartile into 25%.
हाँ, तो क्या करते हो आप? It is median, okay? So quartile 2 is same as median, correct?
Yeah.
So you divide the data into two equal halves first. That is creating median. Done. Once you create the median, then you create median again on the left side data set. Okay, so जो left में again you create a median, half. So half of half is 25%. So Q1 becomes median of left side data set. And Q3 is median of right side data set. Okay. So your quartile 1, Q1 divides data set into 1/4 to 3/4. Okay. Lowest value is also called as Q0. So range you can also say Q4 minus Q0. Q0 is lowest, Q4 is highest. Okay. Q0 will be here. Okay. It's called lowest. Then Q1 is 1/4. Q2 is median 50%. And then Q3 is 75%, Q3, and Q4 is highest. Okay, so range you can also write as Q4 minus Q0. Okay, highest minus lowest. Quartile, interquartile range IQR is Q3 minus Q1. Yes. So these are metric for variability. Okay, so interquartile range. Okay, and when you have interquartile range, you can represent the data set into box plot. Okay, so we have spoken about frequency table and bar graph and histogram, bar graph, histogram, pie chart. Then scatter plot. This is another plot. Okay, this also works on only one data set, but you can have box plot for multiple data. Okay, so your box plot represents those quartile values. Quartile data can be converted into box plot. So box plot is like a box. Okay. I will show you in Paint. Can you see my Paint screen? No, not yet. Now I should be able to see, correct?
Yeah.
Okay. So box plot is box, draw a box like this and put a line in between. Then you have two handles here. Okay, this is called as box plot. So you have a rectangle, which is box. Inside that, you will draw a line, and then you have two handles. What are these handles and the line? This is your lowest value, Q0. This is your Q0. This is your Q4. This is your Q2. This is your Q1. And this is your Q4. Sorry, Q3, right? Q3. Q3. So box rectangle represents IQR, Q3 and Q2. Q2 is your median. The line in between the box represents the median value. And the two handles represent your minimum and maximum value. The two handles represent your minimum and Maximum.
Maximum.
Some box plot will have a points also, dots also. Some box plot will have dots also. Okay. So these dots are called outliers. When it will not be near to handle, it will be somewhere here, right? So these are called outliers. So box plot, if you create box plot, it will identify outliers. You can see the outlier. So box plot is the only plot which can clearly tell you that this is outlier. Other plots, you'll have to see the plot and see, oh, okay, this looks like outlier, but box plot will mark them. So when you have a box and you see a dot near the handle, it will be near handle only, outside the handle, okay? That means those are outliers. Make sense?
Yeah.
Okay, so these are outliers. So we'll stop here today. Okay. And